What programming languages are used in embedded firmware development? Attention electrical engineers and tech enthusiasts. The conversation today centers on a hot topic. What programming languages are essential for embedded firmware development? With the rapid advancement of technology, understanding the languages that power our devices is more important than ever. As we look at the latest trends, one language stands out as the most widely used in embedded firmware. See, this language provides direct access to hardware, making it ideal for low-level programming. Its efficient memory usage and predictable execution times are key factors that make it a favorite among firmware developers. From simple microcontrollers to complex system-on-chip designs, C is the backbone of many embedded systems. Next up is C++. This language is gaining traction, especially in projects where object-oriented programming is beneficial. C++ allows engineers to manage larger codebases while still focusing on performance. It is commonly used in consumer electronics and industrial controllers, often in conjunction with C. However, developers typically avoid features that could bloat the code or slow down execution in resource-constrained environments. Assembly language also plays a role in embedded firmware, particularly for tasks that demand utmost performance or specific hardware control. While it is not the primary language for most projects, you might find assembly used in bootloaders or interrupt handlers where timing is critical. Most projects will combine a small amount of assembly with more extensive C or C++ code. For those working with programmable logic devices, hardware description languages such as very high-speed integrated circuit hardware description language are essential. Engineers use these languages to describe digital circuits that operate in parallel on chips like field programmable gate arrays. This approach is distinct from traditional firmware but is crucial in certain industries. Languages like Python and MATLAB are often used during the development process for simulation, testing, and data analysis. However, they are not typically included in the final firmware that runs on devices. Their role is more about supporting the design phase rather than being part of the embedded system itself. In terms of security and safety, many developers follow coding standards like Motor Industry Software Reliability Association C or Computer Emergency Response, Team C. These standards help minimize bugs and vulnerabilities in firmware. Tools for static and dynamic analysis are also employed to catch issues such as buffer overflows, which can be a concern since firmware often lacks the memory protection found in larger systems. To sum it up, C and C++ dominate the landscape of embedded firmware development, with assembly and hardware description languages filling specific roles. The choice of language is influenced by hardware capabilities, performance requirements, and the type of system being built. Understanding these programming languages is essential for anyone involved in the field of embedded systems.